All right, so today what we're going to be doing is we're going to start talking about quadratic functions, okay? So before we start this lesson, I want to talk about what you already know. So tell me the first thing that pops to your head when you hear the word quadratic. X squared, what else? Parabola, what else? Factoring, okay, what else? GCF, okay, what else? Anything that pops up with quadratics, think about it. What else do you know about them? What have you learned? What are some other words that come to play? Different V word. Zero product rule, okay, what else? Not everybody at once, it's overwhelming. Started with a V, what was that word, John? Vertex, good, what else? Maximum and minimum, excellent, what else? Intersection points, okay, what else? What? Line of symmetry, excellent, that's a great one to talk about. Axis of symmetry, right? Line of symmetry. Who remembers the formula you have to use to find the axis of symmetry? Last period knew it, come on. What's the formula for axis of symmetry? X equals okay, I guess we're starting from there. All right, so a lot of what you just said is what we're going to be talking about today. Maximum, minimum, vertex, turning point, quadratic, right? All of these things go along with quadratics. So we're going to continue on that path and go a little bit deeper. You guys ready? Turn the page. Okay, so first thing we need to talk about is standard form. That's just the way that this quadratic is written. There's multiple forms that we can write quadratics in. This is the one you'll see most often. Ax squared plus bx plus c equals 0. Is this an equation or expression? Equation, why? It's got an equals in it. Okay, so we could also say y equals ax squared plus bx plus c. That's the way we're used to seeing them if we're going to be graphing them. Okay. The domain of a quadratic function is all real numbers. What's domain? All my x values. What's range then? Y. Okay, so the domain of any quadratic function, did I say any? Does that mean all? Yeah, okay. Is all real numbers. What does that mean, all real numbers? Can't have imaginary. Can I have everything else? Good. Okay, next page. All right, so some of the important information here. This should say x equals, I apologize. Ooh, that's ugly. Okay, a graph of a quadratic function is a parabola, right? The axis of symmetry, x equals negative b over 2a. Is it coming back to you? Yeah, the axis of symmetry is x equals negative b over 2a. X equals is what kind of line? Vertical or horizontal? Vertical, okay. So x equals negative b over 2a is a line that divides the parabola into two mirror images, right? It's your axis of symmetry. It cuts it in half. Agreed? Okay, the vertex of the parabola is the point at which the parabola intersects the axis of symmetry. We also call it the turning point. Why do we call it the turning point? Yeah, it's turning from going down to going up or going up to going down. It's turning around. We call it the turning point, okay? Will your axis of symmetry always pass through your vertex? Yeah, absolutely. Okay. So the y value of the vertex of a parabola represents the minimum or the maximum value of the function, okay? How do I know if it's a minimum or a maximum? What? If what's positive or negative? The x squared. Okay, I'm going to go back to this standard form. What letter here, what variable, has to be positive or negative to tell me up or down? The a. Okay, so if the a is positive, what is it? We have a minimum. Great. If the a is negative, it's a maximum. Are we okay with that? Great. Okay. So we're going to graph the function f of x equals 2x squared minus 8x plus 8. F of x, what's that mean? Y. Okay. F of x means y. What's g of x mean? Okay. How about m of x? How about d of L? How about c of d? Are we getting the point? Yeah, does it matter what the variables are? Does it always have to be an x on the inside? No. Okay, so when we're talking about function notation, guys, it's not always f of x. It can be anything. It can be height in terms of time, h of t. Okay, it can be meters in terms of seconds, m of s. Do you understand? Okay. All right, so we're going to graph this function, and we're going to find the vertex, the axis, symmetry, the domain, and the range of the function. So I probably need to insert a graph page. So go ahead and insert a graph page. And we're going to graph 2x squared minus 8x plus 8. How do I graph it? Enter. Okay, so what did I need to find again? Vertex, axis of symmetry, domain, and range. I have a lot of tabs open. Okay, so I want to find all of that information, right? What tool in my calculator allows me to find that information? Menu, good. Nope. Geometry. Points and lines. Point on. Do you guys remember how to use this? Point on. You're going to click somewhere on the graph. I suggest away from the vertex. Okay? Once you click on that graph, by click I mean press that center, right? Center of your nav pad. I want you to hit enter so it drops the point. Is your point dropped? Once your point is dropped, you can drag the point, grab it and drag it. How do I grab something? Control click or hold down click. Okay, grab that point. I want you to drag it until you're gonna see a little pop-up. It's gonna say something. Click, control click to grab the point and then drag it. Okay, what's it say? Yeah, when I hit that vertex, what's right there? It says minimum. So what is my vertex? 2, 0. Okay, in here. So let's go back. Let's talk about this. My vertex again was the point 2, 0. If my vertex is 2, 0, what's my axis of symmetry? 2. How'd you get it? We could do it that way, and we will. We can use the formula. Yeah, it's going to cross through that vertex, isn't it? Hello. That was weird. It's going to cross through that vertex. At what point? 2, 0. So what's the x value? 2. So my axis of symmetry there is x equals 2. It's always an equation of a line. Your axis of symmetry is not 2. It's x equals 2. Does that make sense? Okay. How would I get that algebraically? If I had x equals negative b over 2a, how would I get it using that formula? Where's the b and the a? Where do I get those? From my equation. Good. Okay, what's 2 represent? Negative 8? Positive 8? Okay. So, what's b? Negative 8. What's a? So we get x equals 8 over 4, which is 2. So do I get the same thing? Okay. So should you ever get axis of symmetry wrong? No. Especially since you can use point on, find your vertex, and then it's just your x value. Okay, so what's the domain of my quadratic function? What's the domain of my quadratic function? Turn back 2 pages in your notes. Tell me, what is the domain of my quadratic function? I would need more than x values. Turn back 2 pages. What is the domain of my quadratic function? Say it again. All real numbers. Okay, so we have a couple of ways we can say that, okay? First way that we can say it or show it is that double backed R. That's notation for all real numbers, okay? Double backed R. So it's two parallel lines and then the R, okay? So another way we can write it. Negative infinity to positive infinity. Another way. Do they all mean the same thing? Yeah. All right, let's talk about notation. What is this notation called? Gotta know these things. What is this notation called? What notation is this? So on the Regents exam, if I told you to express your answer in interval notation, you would do what? The first one. Good. This is interval notation. And the second one would be, it's a good thing we're talking about this. Everybody's writing these down, right? No? It's called set builder. Okay, interval notation, set builder notation. So there's your domain, right? What's range? My y's. Okay, so I want to know what my range is for this quadratic function. Let's look at it. We don't need to look at the table. Just look at the graph. You told me range was what? Y values. All right, what am I using? Sure, I'm using 0, that it? Huh? No. I'm using all the positive what? All the positive y's? Okay, but what about 0? Is 0 positive?
You're using 0 and all positive y's.
I'm using 0 and all positive y's. Okay, that's an interesting way to say it. How can I say it mathematically?
Numbers equal to or greater than
Just positive integers? What's 0?
if you're negative. 0
0 is greater than or equal to positive infinity. That's definitely one way to say it. 0 is 0, not the word I want to use, though. I know, this is tough, isn't it?
Why?
What? She's right. Y has got to be what? I'm making you struggle through this, guys. Y has got to be what? Talk to me. You just said you were right. Y has got to be what? 0 to what? Where am I going? Just 0? Got to be greater than, just greater than? Can it be equal to? So I can say y has got to be greater than or equal to 0 for my range, right? Okay, so building off of that, let's talk about interval notation and set builder notation. Interval notation. What am I going to write that shows this? 0 to what? What kind of brackets do I use? The squared for the 0. Why is this one squared? Because I'm using it, right? It's equal to. Okay, what about the infinity? That's a parentheses. Why? It's not really a number, right? Okay. All right, so that's interval notation. How about set builder? 0. That's what you're equal to? Y. Great. About less than? Infinity. Okay? Interval and set builder. You better know the difference. And notice for the set builder for range, I used Y. Why didn't I use X? Okay, we're not dealing with domain. We're talking about range, right? It's the Y values. Good. You guys doing okay? Okay. Okay. Here's my vertex, right? What do you notice about the Y value? 0. What do you know about my range? Starts at 0. Think that's connected somehow? Yeah. If we think about range, right? We're thinking about range. I know it's all of the y values that are being used. My function is starting here. It's going up to infinity. So if my turning point is 2, 0, 0 is going to be that first value being used. How about if my turning point was -3, -1? Yeah, -1 to infinity. You guys okay with that? So you can use that y value. All right, let's move forward. Next page. All right, so let's talk about quadratic modeling. All right, so if I have 3 points, I want to find a quadratic function that includes those values, okay? So on the next page, you're going to find a table with those 3 points. Generally speaking, what do we do with a table if we wanted an equation to match it? We made a scatter plot, great. And then what did we do with that scatter plot? Found the, somebody said it, regression, right, okay? So we're going to make a scatter plot, and that's going to be done on what kind of page? Data and statistics, and then I'm going to find what kind of regression? What are we talking about here? Quadratic, okay? All right, so next page. I've got a nice table for you. Is it always going to be put in a table for you? No. Okay, so I've got 3 points. I've got the point 2, 3, 3, 13, and 4, 29. I want to create the scatter plot. What do I need to insert? Control doc. Ooh, ooh, ooh. And we're adding a data and statistics. Any rhyme or reason to those points? Nope. What do I need to do? Add my variables. What was my domain? X. What was my range? And there's our quadratic. Does it look like a quadratic? Doesn't. Am I looking at the entire graph? Okay. No, I ain't. Ain't is not a word. Okay, so we're going to go ahead and find the quadratic regression. Who remembers? Hold on. Ah, I'm going to make somebody do it for me. Somebody that hasn't touched it yet. I don't know who this is. They're making you work. Carrie. Okay, I want the quadratic regression. Somebody walk her through it. Menu, good. 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 She's getting there. A little lag. Okay, good. So here is our quadratic. I've got y equals 3x squared minus 5x plus 1. Just try it again. Okay. 3x squared plus negative 5x plus 1. There's our quadratic. Any problems getting the quadratic? Go ahead and turn to the next page, Carrie. Okay, so what we're going to be doing with these is word problems. Okay? The majority of this unit is applications of quadratics. Now, are they all going to be pretty? No. Is the real world pretty? Are we always going to have nice integer values? You have to get used to it. Okay? You're not going to get pretty values all of the time. Okay? So please get used to that. So the problem says, the table on the next page shows the height of a column of water as it drains from its container. Everybody close your eyes. Close them. I want you to picture a column of water. Everybody know what a column is? Okay, picture a column filled with water. It's like a cylinder. Okay? I want you to picture that water draining out from the bottom. Tell me what's happening to the height of the water. It's decreasing. Good. So that water level is decreasing. In terms of time, as time is increasing, what's happening to the water level? It's decreasing. Okay, open your eyes. All right, so we're going to model the data with a quadratic function. We're going to graph the data and the function. And we're going to use the model to estimate the water level at 35 seconds. So we've got a couple things to do there, right? Turn the page. Okay, so what's my domain? Time in seconds. Very important that you notice the units of measure. Time in seconds. Range? Water level in millimeters. So my domain is time in seconds. My water level is in millimeters is my range. So notice as time is increasing, the water level is decreasing. So I need to graph this. How? Control doc, and you're going to add a data and statistics. Good. What was my domain? Time in seconds. Good. Make sure that your domain matches what was in your table. What was your range? Go ahead and find my regression, please. Yep. And then just wait, please. Is it pretty? No. Is it okay that it's not pretty? Yeah, absolutely, guys. They're not always going to be these beautiful functions, okay? So it's not pretty. That's okay. Okay, so we have, hello, our function, y equals 0.009167. Thank you. Okay, so if this was on a Regents exam and I saw this pop up, would my next step be to do this? Why am I not doing that? It's not the same, guys. Did it ask to be rounded? So should you be rounding at any point until that you are completely done? No, you always use the full equation, okay? Unless it specifies otherwise, which in this case it did not, you use the whole thing. Is it pretty? No. I don't care if you don't want to write it, you still have to, okay? So it's not pretty. Okay, so we've got it graphed. We've got the equation. What else did it ask us to do? What else did it ask us to do? Yeah, so water level at 35 seconds, right? All right, so tell me, how do I figure that out? Plug what in? We're going to plug in 35 for x. Why not y? Good, say that again. X is my, good, x is domain, and my domain is in seconds, right? Time, seconds. Okay, so we're going to plug that in for x. Now, are you going to do it the long way or the short way? Okay, so we should have inserted a calculator page. Hello. And we're going to store, okay, here's the thing. It's not going to let us store x. Here's the reason why. We had a table in here. What was the domain for one of them? It was x. So instead of using x, let's use t. T stands for? Okay. So we're going to say t, store it to be 35. No. Then we're going to type in our equation, 0.009167 t squared, right, minus 2.10357 t plus 120.333. Am I good with that? Did I type something in wrong? Yeah, I did. I'm going to bring that up and just borrow it. I see what I did. I have multiplication instead of subtraction. There we go. Is that better? Cucci fails. I fail. Failure. That's all right. That's better. Okay, no. I want everybody to look at, I want everybody to look at your table. Go back to your table. Table, 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 table. There we go. Okay. How are the heights written? Sure, in millimeters, but what do you notice about all those values? Sure. Think simpler. They're all numbers. What kind of numbers? Sure, they're all real numbers. They're not decimals. What are they, Gia? They're whole numbers. Okay, they're nice and pretty, aren't they? Okay, so let's go back to my calculator page. And I want that to be a pretty whole number. Yes, rounding is good. Pretty whole number would be 58 what? Millimeters. Great. 58 millimeters is going to be your answer for that one. Nice job. 58 millimeters. All right, Carrie, why don't you turn a page ahead again, please? All right, now, this is a two-part question. You're going to use your model to estimate the water level at 25 seconds and then again at 3 minutes. Now, am I going to retype that entire function? That would be silly, right? I just need to restore and find my answer. So go ahead. Go back to that calculator page, and I want you to find those two values, please. You too. You're not excluded from this conversation. Get to work. So I want you to think about your units, okay, Mark? We have 205. Okay, those are two separate problems. 25 seconds and at 3 minutes. Yeah, good. Two separate problems, guys. You're finding it at 25 seconds and then again at 3 minutes. Are we ready? Okay, ready? Okay. So she found 25 seconds, and that's going to be approximately what? 73. 5 and above, give it a shove. Is it a 5? No, it's a 4. Okay. Nope, you can't do that. If you're going from, guys, whole numbers, we're not doing this and then rounding again. That's not how it works, okay? If you're rounding to a whole number, you're looking at that 3 to the 4. Does it go up or does it stay? So it's approximately 73 millimeters. Okay, 3 minutes. She put in 180. Why?
180 seconds.
180 seconds. Our units are in seconds, okay? So she gets approximately. Great. How are we doing? Okay. Now, your homework is pages 1 through 4, but that's for today and tomorrow. So after tomorrow, you'll be able to do everything in there. Just start what you can do. You'll be able to do quite a bit of it, okay? And then again, same thing tomorrow, 1 through 4. So we're going to be continuing to kind of explore these quadratics tomorrow. Any questions?